Welcome to class PM. The last class we have studied about how to measure the speed, right? We have learned the formula like distance traveled by an object by the total time taken. So we know that if you know the time, which is the time taken by an object, we can calculate the distance, or we can tell whether an object moves at a faster rate or at a slower rate. So now when you talk about this time, how do you calculate, how do you measure the time? Right? So this class we are going to learn about measurement of time. In olden days, our ancestors who were present, they used to assume that this time, there was no wristwatch nor a wall clock, nothing, right? They used to look at the length of the shadow and they used to tell us the time. In the same way, until till date also there are few people, our grandparents, who just look at the shadow and tell us the time without looking at the watch, right? Is that not a surprise? Right, of course. So they have set their minds in such a way that at every interval there is a particular interval where every season is repeated, and they also know that every day there is a sunrise and every day there is a sunset, which will tell them that the day has begun and the day has ended up. And the same way they know that the seasons are caused due to the revolution of the earth. That means they know that the year keeps moving. The year keeps moving. We know that year by year passes away, right? How did they calculate that year by year passes away due to the revolution of the earth? Now you might have a question, how do they know, like when does the month begin and when does a month end? They used to calculate the beginning of the month and the end of the month by looking at the new moon. Like as the new moon starts, that means the beginning of the month, and as till the next new moon, This is how they used to count. And now when we need to measure the intervals of time which are shorter than a day, then what do you use? Obviously you use clocks and wristwatches, right? And do you know how does these clocks and wristwatches work? Right, these clocks which are present, they work on principle of periodic motion. If you remember, we have learnt about this periodic motion in class 6, right? So they work on the principle of periodic motion, and the well-known example of the periodic motion is a simple pendulum. Now let us learn about this simple pendulum, and I'll tell you how the simple pendulum works. So the simple pendulum is nothing but, a simple pendulum consists of a metallic bob or metallic plate. If you have noticed, the wall clocks nowadays, they have this arrangement of small metallic balls inside. So this is a construction of a simple pendulum. You can see that this pendulum is nothing but it has a small metallic ball, or you can also tie a piece of stone. In case of simple pendulum, you can see that it is a small metallic ball which is fixed firmly to a iron stand, which is fixed firmly to a rigid stand by thread. Okay, so the simple pendulum is nothing but it has a small metallic ball, or you can fix a stone also which is fixed firmly to a stand by the thread. Now how does this simple pendulum will help us to understand the time? Now the simple pendulum is said to be at rest. That means it is not moving, it is said to be at rest. This means it is at mean position. Now let us mark this mean position as O. Now slightly move the pendulum. This ball of the pendulum is called as bob. What is this called? The metallic ball is said to be the bob. Now slightly move the bob to one end and release. That means you're trying to slightly move the bob to one end and release. Please see that when you're releasing the bob, you see that you don't push it. Leave it. So you see that when you move this pendulum to one end, that is when you try to move this pendulum slightly, yes, you see that when you move this pendulum slightly to one end, say like one extreme position, say like when you are moving it towards A and leaving, you see that it comes and goes this way, and then it moves to the extreme position A, gets back to the O, and then it again moves to extreme position B and comes back to O. So this one complete oscillation, this is said to be oscillation. This one complete oscillation of the metallic ball from the mean position to the one extreme and to the other extreme is said to be one oscillation. It is said to be one oscillation. So when you see that when you start moving the bob from the rest position, this is at the rest position, when you slightly move the bob to any of your extremes, you see that it goes to that extreme, gets back to the original position, okay, O, and goes to the next extreme and gets back to the position. So this one complete oscillation from say like O to A and then back to O and again O to B and back to O is said to be one complete oscillation.